In the last videos, we looked at using fit y by x and fit model to make an inference about treatment effects in the population. That is, we tested the null hypothesis for whether all those TOS sub j's are really equal to 0. And in our case, we found evidence that not all the TOS sub j's are equal to 0. That is, we have evidence that the factor of airline actually matters in the cost a person is paying. But notice that this effect, or this inference, is really about the factor altogether. And this is what we would call a main effect test, the main effect of the factor. Let me give you a definition for main effect. A main effect is the overall effect of a factor. So an hypothesis test for a main effect is a test of whether there is evidence for an effect of different treatments, that is, the levels of the factor in the population. And our main effect test is rather nonspecific. In our case, we only had 3 groups, but sometimes we have groups that number in the hundreds. So a main effect test is really an omnibus test. It is a test at once of all of the different group means, and giving us evidence, if we reject the null, that there are differences somewhere amidst all those different group means. Now, this omnibus test, or this main effect test, is of interest to us when we want to know whether that factor matters. But often, we need to make follow-up comparisons to determine which mean differs from which other mean. And this is called a pairwise comparison. A pairwise comparison is an hypothesis test about a specific mean difference. In essence, with the independent samples t-test, we were doing a pairwise comparison. That is, we were making a comparison between a specific mean difference. In the context of an analysis of variance, we'll do pairwise comparisons when we're interested in following up on that omnibus test. And on occasion, it'll be the pairwise comparisons that are of greater interest than that overall ANOVA. So let's take a moment to see how we'll do pairwise comparisons using JMP. I'll again use the hypothetical data for cost of flights, which is available in the JMP journal. I'll also use the hypothetical IQ data for 1,000 people taking 20 different drugs, which is also available in the JMP journal. We'll see that we run into some particular issues when we have a dataset like this, where we have many possible comparisons. Notice that when we have 20 different drugs, there are many pairwise tests we can run. In this case, it's every drug versus every other drug. And with 20 different drugs, that's a considerable number of different pairwise tests we can run. Let's start with the hypothetical data for cost of flights. What I have open is the fit y by x and fit model analysis for the cost of flight data. We produced these analyses in the previous videos. Let's start on the left with the fit y by x platform. To produce pairwise comparisons, let's first think about what a pairwise comparison result could show us. In this case, we have 3 groups, so we actually have several pairwise tests that we might be interested in. The first would be Delta versus Southwest, the second, Delta versus Virgin America, and the third, Southwest versus Virgin America. Notice that 3 tests encompass all the possible pairwise comparisons we can make. We don't have redundant tests like Virgin America versus Delta after we produce a test of Delta versus Virgin America. Notice these tests are, in essence, the same. So, to produce our pairwise comparisons, we'll go to the red triangle and select an option next to compare means. We have several different options, but we're going to talk about the first 2, each pair students T and all pairs Tukey HSD. Let's start by selecting each pair students T. What this will produce is output at the bottom, which shows us the comparisons of each group versus each other group. Let me go to the top and hide some output so we can look more clearly at what each of these tests is referring to. I'll actually hide the LSD threshold matrix as well, and I'll hide for now the connecting letters report. Let's first start by looking at the ordered differences report, which reports for us each comparison, the standard error of the difference and the actual observed difference, the confidence intervals for the lower and upper bound, and a p-value. This p-value is reporting for us the probability of observing a difference as extreme as the one we observed, or more between those groups, if the null hypothesis is true. The null hypothesis for each of these tests is that the difference is 0. So what we have in this table are those 3 tests we talk about: Delta versus Virgin, Delta versus Southwest, and Southwest versus Virgin America. These tests are ordered by the magnitude of the p-value, with smaller p-values at the top of the table. That's why it's an ordered differences report. In addition to this report, the connecting letters report will be of use when we have many possible comparisons. Let me show you what that report is showing for us here. In this report, we're looking at each of the different categories, and what we want to pay attention to is the letter next to each category. The way the connecting letters report works is categories that don't share a letter are statistically significantly different by the criterion we've selected. The criterion by default is an alpha of 0.05. If you wish to change this criterion, it's under the red triangle under Set Alpha Level. For now, let's leave it on the default, which was alpha of 0.05, and let's work through how we would interpret this connecting letters report. What we're seeing here is that delta is different from Southwest statistically significantly. The way I can tell is that delta has the letter A and Southwest has the letter B. Neither of these levels share a letter. So delta does not have a B and Southwest does not have an A. What this means for us is that these two are different at the 0.05 level. We can also see this under the ordered differences report. Notice that delta is different from Southwest at 0.0415. We can also see in the connecting letters report that delta is different from Virgin America. If we look under the ordered differences, delta versus Virgin America, our biggest difference was statistically significant 0.0006. Now, look at Southwest and Virgin America. They share the letter B, which from the connecting letters report should tell us that those two levels are not statistically significantly different. If we look at the ordered differences report, we can see the p-value for that comparison was 0.4785, not statistically significantly different. So the connecting letters report in essence tells us the same thing as the ordered differences report, but it does so in a very parsimonious way. Simply looking at which levels do not share a letter allows you to tell very quickly which levels are different from which other levels. Let me scroll up and let's take a look at the graphic that was added to our plot. What we have here is a representation of the each pair student's t-test, but done graphically. The size of these circles are the confidence intervals of that individual mean, and when I select any particular mean, the circles that are strongly grayed are actually statistically significantly different from the mean I selected. In addition to this, the mean I selected, which is red in the table, is statistically significantly different from any of the italicized means. Now let me click on one of the intermediate means, in this case Southwest. Notice we had evidence that Southwest was different from Delta, so this is strongly bolded, but the Virgin America circle did not get bolded. If we look at the legend, Southwest is our selected mean, Delta is italicized, it is statistically significantly different from Southwest, but Virgin America is not. That is, it is not italicized. So this is an easy way also to click through your means and see which comparisons are statistically significant. Again, this will be useful, especially when we have many comparisons to consider. Now I'm going to scroll down and I want to click the red triangle next to the comparison for each pair, because we have one additional option that'll be useful to us when we're looking at many comparisons, and that is the Detailed Comparisons report. When you select this report, JMP will print out the t-test reports that you would get if you were considering just those two means. So we'll get the more complete report, including the representation of the sampling distribution of the mean difference. Now these p-values, the two-tailed p-values, will match the p-values that are given in the ordered differences report. But often, especially when we're reporting the results of our tests, we'll need the t-ratios that are associated with each test. So these t-ratios will be what we'll want to report.